Okay, so today is a quantitative analysis workshop, and the goal is really to hopefully, again, you have data, and the goal is to get your data uploaded, do a little bit of data management, and then certainly be able to conduct your analyses in a rigorous fashion, and then export that APA formatted document and take it from there and kind of move you along the process. As I say, Melissa and Ashley will be monitoring your Q&A. And again, you try to get logged in if you can. Okay. So, okay, the agenda, we're going to understand some of the basics. Not everyone has the basics, so it's important to kind of get what an IV is, what a DV is. We'll talk about creating an account. How do we set up our data? How are we going to conduct the analyses? And the tool is very robust, intellect to statistics. It really does descriptives to structural equation modeling, and then how to download and edit your document, and then a final Q&A. Okay, so let's just get to the basics, and I'll burn through this pretty quickly, or my intent is to burn through it pretty quickly, as to not to bore the folks that know, but if you don't know, you need to know. So there's really 3 levels of measurement: nominal, Latin for name only, male, female, Republican, Democrat, independent. Ordinal is just ordered data, and scale is just a number. So let's just talk about nominal. As I say, it's just really categories. All right. There's no ordering, there's no ranking. It's just what the label is. Okay. Like banana, orange, apple. Okay. Ordinal, we actually have names, but those names are now ordered. Okay. So, small drink, medium drink, large drink. Doesn't have to be equal sizes. It could be 8-ounce drink, 12-ounce drink, 32-ounce drink, but they are ordered. Again, there's activity level as an example. Again, there's not equal intervals in between that order, but nevertheless, they are ordered. And then finally, scale, which includes interval and ratio level measurements. This is just individual numbers, and that the important part is that the intervals are equal. So someone that's 1 to 2 years has 365 days, and someone who's 65 and 66, 365 days. So equal intervals in between years. The important of level of measurement, I should say, the important is that some of the tests only deal with certain levels of measurements of your variables. So if you wanted to run a t-test and you have only nominal variables, not going to happen. So that's the importance of knowing levels of measurement. Okay. Let's go down to basics of what a independent variable is, IV, dependent variable, DV, and covariate. And then I'll go through this. So let's see. So in this example, we're going to use the fruit as the independent variable, okay, because it's just labels. And we're going to say, hey, you know what? Is there different energy levels based on the type of fruit that you eat? Okay, and we'll go through this. So the dependent variable in this case is depends upon the levels of fruit. So the dependent variable is the energy level, okay, that you might get, or the sugar content, some outcome variable based on that IV. Okay. And then here I just show that we have our 3 types of fruit below. Here's our energy level on the y-axis, and different level energy levels based on each fruit. This is mock data, by the way, so oranges could have more sugar or things of that sort. Okay. Covariates are variables that you're trying to control for. So I'll just use the example that, if you were in a race, you said, gosh, is there differences on, 5K time by gender, right? The time is our dependent variable. How fast do people run? Our independent variable is gender or sex, male or female. But we notice all of the males happen to be, 25 years old, and all the females happen to be 65 years old. So we think, look, if males have a quicker time, it may not be because they're just male, maybe because of their age. So I want to neutralize the effect of age or use it as a covariate. And there's different types of analyses that allow for confounding variables or variables that might be influencing the outcome variable. And we want to control for that. And that's basically what a covariate is. As I'm going through this, I realize how fast I'm speaking, just to know that everything's being recorded and you can go back to it as well. Okay. So off to create an account. Now it's time for the interactive section of the webinar. Give you a moment to get logged in. Again, if you have not created an account, please use the link or type in the link if you would. Okay. And Melissa, how will I know if everyone is logged in who wants to be logged in?
So we won't know if everyone, if you want to put it in the Q&A and let us know you're in, time to move forward, that would be helpful. We'll give everybody a few minutes though.
Okay, that's fine. And as I say, and if you just want to watch the show, no worries at all. You can just watch the show. But if in fact you do want to make this a real workshop with your own data and you need help, reach out to Melissa or Ashley there. And okay, while you guys are all logging on, common problems in data analysis. This comes from 30 years of hearing the same things, which is I don't know which test to conduct. By the way, that depends upon levels of measurement and the phraseology of your question. Okay. And let me say something more about that. So if you, for example, if your question is, does A predict B or influence B or impact B? That's kind of, we're in regression land, okay? Are there differences on energy level, sugar level, satisfaction level by some independent variable? We're kind of in t-test land or ANOVA land. And relationships are either in kind of chi-square land or correlation land, again, dependent upon that level of measurement. So we can talk about that. I'm happy to take questions about that. And I'll give several examples of each of those three that I just mentioned. How to conduct it, a lot of the tools have not been so simple. I've counted over 300 dropdowns from SPSS, a little bit intimidating, and it's not so easy to navigate that. Not only you can find the test, but well, where are the assumptions of the tests? How do I find that graphically or quantitative assumptions? Well, in the Intellectus statistics tool, they're all built in. They're all built in and interpreted for you. So it's very, very simple to find the test. And once you know what the test is, to actually conduct it in Intellectus. And then what does the output mean? Again, a challenge. You have raw output. Too often, I'll say, that there's really a lot of signal, which is great. Want to know what the results are, but a lot of noise too. So things in the output that kind of just blur what the real signal is. So we've solved that problem by having interpreted output in plain English, and I'll show you that as well. So, okay. And I think with that, loading up your data. Okay. So let me get out of here. So let me just do something here. And let me just download this data for a second. Okay, so let's just get to so if you're logged in, you should see this screen here. And we'll be dealing with several of these buttons. So let's just go to upload data. So I have a CSV file here. So I'm going to go to upload data, okay, and click on CSV. And then I'm going to choose my file. In my particular case, it is the master class. Okay, and then click upload. There is a data cleaning wizard, but I'm going to hold off on that for a moment. Well, maybe maybe I will go through it. Okay, let me go through the data cleaning wizard. This is a new feature that we've added. And let's just get to it. So one of the things is that sometimes when you upload from Qualtrics or SurveyMonkey, they have several rows of headers. So this would have been an opportunity to, delete a header that you don't need. In this case, we have our labels and the data is right underneath it. Everything looks great. Let's go to the next. The editing variable names, if I wanted to just put age, okay, for example, you could just edit the variable names, okay. Click off that, and then apply changes. Okay. So you can edit the variable names. This is helpful if you have, sometimes the whole question is in there. You really don't want that. You want kind of a short name. Okay. No misspellings. We have a detection if there's misspellings, like there's a male with a small m and a male with a capital M. They both indicate male, but they're coming up as different levels. So that would be the opportunity here to kind of to merge those together. And then Likert type scales. This is really helpful. So I think what I want to do here, I'm going to upload the different data set just to show you that one functionality. Cancel. I want to go back for a moment. So I want to get to Excel, choose file. Okay, so let me just open that. Because very often you do have subscales. Some items are reverse coded, and we kind of want to get to it. So let me just click through some of this. Oh, maybe go back. Get rid of my two headers. I'm not going to change my names. I'm not going to change my variable names. Here is that merge. So I can, as I said, disagree's got 3 E's and 2 E's, and I could just kind of apply changes. So it's just merging these disagree, disagree, and disagree. It's just merging them. And last one. Okay, great. So yes, I do have Likert type scales. So here's an opportunity to really select the type of agreement scale, the type of Likert type scale you have. It goes from 3-point all the way up to 7-point. And then once you've identified the correct labels, so I want to change these strongly disagree through strongly agree into 1 through 4s. I can then check all, and I'm going to convert those labels. We go back and show you again. Yes, I do. So here I have the labels in there, but I need numbers to be able to add them together. So select my agreement level. I do want to change all of those 1 to 4. Don't worry about reverse coding at the moment. Just changing those labels to numbers. I want to apply changes. Great. And then go to next. So this is where I can add a subscale on a fly. So really, if all of these items were, in this case, creating a self-esteem scale, but I knew that items 3 and 7 were reverse coded, and my range was from 1 to 4. So in one fell swoop, I can say I have a total self-esteem scale. The directions were to average those items. I've identified the items in the subscale, the items to be reverse coded, and then the range of that reverse coding, and click apply change. And next, we suggest add an ID variable, just so you know who is who. And when we finish, just click continue. Here is our clean data set, or cleaner than it was before. So in particular, changing all of those, excuse me, labels to numbers, and then create an appropriate subscale there. Okay. So that's how we get data in and manage some of that data. There's also, you can see that we've also hopped right into this other data management set of options. And here you can, create composite scores here. You can transform variables if they're skewed. You can reverse code. So there's different options, all with a helpful scroll over, by the way. Okay. And then certainly you can download your managed data. So we've created total self-efficacy or self-esteem, and you can see here that we have our downloaded data with our new variable there. Okay. Let's just go back to this data set. Melissa, I'd like to know if there's any questions at the moment before I go on about, hopefully people are logged in who want to be logged in, about uploading data. Do we have any questions about that?
None have come through so far.
Okay. Let's just give it a half a moment here, because I want to, I want you to be able to ask questions if you have them. And I'm accepting some of these data sets that you may or may not want to share here. And I wouldn't mind using, are these folks that are here, SA Fields or Building Foundations, SCS? And if you're here, would you mind if we used your data sets as a example here? Let's give a moment there. And if not, I won't use them. No worries.
So if you did share your data and you want us to use it, if you could just put that in the Q&A and let us know.
And then I'm happy to work it through. Okay, go ahead.
Yep. So Charisse, I'm assuming that's the SA field, said you're welcome to use it.
Awesome. Great. Okie dokie. So here we go. I'm going to take over that project. Okay, so here's our data. And we have participant ID, hunky-dory. We have conditions. By the way, we can always look at what's in there by going to manage. And I can see at a quick glance, counterfactuals versus control, all right? All right, and then, so I would just go through and make sure that everything is the way you want it. Okay. You don't want this, if we're going to use this diabetes length, check it out. So if you have it here, you have lots of different stuff going on here. You're going to want to put these on the same metric, okay? So I'm not going to mess with this data cleaning now, but if it's in years or if it's in months, since you had some of these months, 6 months, 15, 6 months, you may want to just put everything in months, for example, and then get rid of these guys that don't have anything by just, going to clicking here and then going to delete. Okay, I'm not going to mess with your data set at the moment. But you know what? Let me do something. let me just duplicate this. And this way I won't mess you up. Okay. So as I say, you'll want to put that all on the same scale, okay? Be it months or years or things of that sort. Paper log, these seem like clean, nominal yes, nos. All right. Same here. You're going to want to put those on the same metric, be it months or years. Blanks, just leave them blank. Okay. XXX thinks it's the label, so it doesn't know that that's different than a time frame. And then this looks like a really ordinal level variable. And for these types of things, and again, I've duplicated it so I won't mess you up here. With these ordinal things, if you wanted to use this, I would probably just make sure that they're in the correct order. Never, rarely, occasionally, sometimes, usually, always, great. But I might want to delete this guy out of there. Because if I did a correlation, a Spearman correlation, I wouldn't want that 1 in 3 individuals in there. I would just delete. And then I'd make a new variable. Okay. So, and then you can see at the end, our new variable limit strat1 underscore ordinal. And then everything else. So we have lots of data here. So I'm just going to go make up research questions. These things, I'd make them ordinal. So you kind of want that correct level of measurement on these things. No days, 1 to 5, 6 to 10. Okay, looks great. So I would just submit that, so changing it to ordinal. Okay, so let's talk about what analysis we should use. So one way to get that is, and let me just write down some of these variables here. So I have weight. I have diet status. Okay. And let me just grab a few other variables here. I think I had, okay, condition, that's important. Okay, and then diabetes. Again, I'd want to make sure that this is exactly how I want it. It seems like maybe this is pre-diabetes 1, 2. So maybe this is exactly what you want. I'd probably get rid of the other, frankly. And then put it into that same variable. So diabetes type. And okay, and condition. So, and what else do I have here? And well, I have a few of those things. Got a fair amount of data. Motivation. So let's just take motivation total. Okay, so we can ask lots of questions based on these, weight, motivation total, diet status, condition, and diabetes. I think it was type. And you know what? I like clean data. So here's what I'm going to do. I'm going to get rid of the folks that I really, again, this is off of the one I copied, okay? So let's just get rid of some of this stuff. Get rid of these guys. So as it turns out, ladies and gentlemen, data cleaning is probably 90% of the job. So if you spend a lot of time data cleaning, that's the nature of the beast. So just know that going in. Conducting the analysis, the interpretation, 30 seconds. Quick, quick, quick. So this is the real real work, so to speak. Not the critical thinking work, but the work of conducting analyses. And okay, and we'll go here. You have lots of variables here. Okay, so let me see if I can just get rid of all of these here. Okay, great. So I have a simple, clean data set with condition, eating disorder diagnosis, diabetes, and motivation total. Lots of questions we could ask here. So one way to figure out what kind of test to do is to go to our decision tree. And typically in decision trees, you kind of walk along and say, well, do I have group differences, or I want to predict an outcome, or do I want to explore relationships? And then based on the kind of data we have, we can kind of get there. So for example, let's just say I want to see if there is a relationship between condition and diabetes type. Okay, so this is, do my manipulation check work? That is, I want to randomize folks, but maybe I have preponderance of type 2 diabetes in the counterfactuals. So I may want to see if there's a relationship or between condition and diabetes type, for example. Okay. So I can go to the decision tree and say, well, I want to explore relationships, okay, to my variables. Are they all scale? Nope. They're all are they scale and categorical? Nope, they're all categorical. So they're all categorical. And do I have an ordinal level variable? Well, I don't. I think they're all nominal. You're either in a condition, okay, one or the other, counterfactual or control, and then you're in one of those diabetes types. So are all of your variables ordinal? No. So I'm doing a chi-square test. Excuse me. So you can play around with either walking along these branches to get to the test, or trying to answer these kind of user-friendly questions. So once I have that, I can click on here to conduct analysis. My data is from my data set, and I want to examine if there's a relationship between condition and diabetes type. That's all there is to conducting the test. That's it. As I say, all the assumptions are built in. So here's our results. In each of these APA formatted results, some of you should be saying, ooh, ah, because typically it's not in English, it's in or output. So there's an introduction, which is stating the test and the variables. Then for each of these tests, as I say, there's a whole bunch of them, that the assumptions are built in. So the chi-square test does have assumptions, and here they are. So it requires all cells to have expected values greater than 0. Expected values are in these parentheses here. And 80% of the cells have expected values of at least five. Okay, so that's again, those are the two conditions. What the tool does is it then bangs through those. All cells had expected values greater than 0. First condition, check. Total of 50% of the cells had expected frequency of at least 5, indicating second assumption was violated. And so, and then when it's violated, we recommend using the Fisher test. Okay. Now we get to the results. So the results of the chi-square were not statistically significant. So, and then here's one way of reporting that. This might be good in this particular data set that, hey, you know what? I didn't have a certain type of diabetes in a certain condition. So this might be a non-significant result, maybe important here. So, and then if it was significant, okay, and here's an APA table, if it was significant, we would just be talking about the observed frequencies. That is, there's 2 pre-diabetics that were in a counterfactual condition. And what we'd expect is 4.41 individuals in that condition. So if it's not significant, as is the case here, I would not interpret it and say there's no relationship between diabetes type and condition, one. And the second thing is, if it was significant, I would just state, there were fewer pre-diabetics in the counterfactual than would be expected by chance. There were fewer folks in the type 2 diabetes in the control group than would be expected by chance. So I would just go and say, here are the ones that there were fewer observed compared to expected, and here are conditions where there was more people there than would be expected by chance. And that's the interpretation of it. Okay, so that's one type of test. That is the relationship test. I can also look for relationships with correlations. And given my data set here, or who volunteered the data set, thank you, I can do a point by serial correlation. Here I select the scale variable, and I only have one, motivation total. And my binary variable, I can have condition. So the question is there a relationship between motivation and which condition I'm in? Okay, is there a relationship there? And again, the researcher may or may not want it to be significant. So it is not statistically significant. So in this, the point by serial correlation was looking at the relationship between a dichotomous variable, okay, condition, and a scale variable, motivation. So those are 2 types of questions and analyses. Okay, I can also ask kind of ANOVA questions or differences questions, like, are there differences on motivation by, let's just say, eating disorder diagnosis? Okay, it's a question. So it looks like we have a little hiccup there with, I'm not sure what the data set's saying here about the, let me just go to another, because I don't got another data. So let's just try condition or diabetes type. Let's try that. So here, as in the other test, the assumptions are built in. One assumption of ANOVA is normality. Basically, it's saying that all of the motivation types look like a bell curve. There's a mean motivation type, and then there's other folks that are around the mean, and then fewer people that have really lower than the mean or really higher than the mean. So that normality is that's what that assumption is testing. Here, it's statistically significant, which indicates that it may not meet that assumption. All right, that assumption is violated. Homogeneity of variance assumption, basically, that's the assumption that these standard deviations are similar to each other, okay, where variance is homogeneous. And here, that p-value was not statistically significant, indicating that assumption is met. Then we have outlier analyses. Be careful here. You just don't want to delete an outlier. So just heads up on that. Sometimes you delete one and then you're playing whack-a-mole, where now this guy pops up over. So just a heads up there. And then the results are in plain English. The ANOVA results were not significant. Okay. Again, it's showing you how to report it. Okay. And you can see that the motivation level for each of these diabetes types, pretty darn similar. Okay. They're not, particularly given the larger standard deviations. What's happening here? For the pre-diabetes type, right? They vary among themselves in that group by 3.92 standard deviations, but they're not even deviating between the groups by that much. So hence, that's why you're getting a non-significant result. If it was significant, we would do a post hoc test. Okay. So APA tables, there you go. And I'll just run one regression and kind of keep things moving. Here, I'll see if I can predict motivation type, and I'll use, condition or diabetes type to predict that. So just condition and type predict motivation. As with the other tests, the assumptions are built in. You can scroll over to see whether that looks more normal or not. Doesn't look normal to me. Heads up, this is templatized. So if you use this output, you want to put it in your own words or use ChatGPT to rephrase that. All right. So we've purposely put things in and turn it in so it's not just duplicated or students are just throwing things into their paper. Of course, you can use the plot straight up. You can use the table straight up. You can use the interpretation. So all of that accuracy and individual aspects are useful, but just be careful with that. Again, you can scroll over to see what looks more homo or heteroscedatic. Other assumptions, and then the results are in plain English. Here, nothing was statistically significant. If it was, it would be interpreted here in plain English, as is the case here. So the model was not significant. That is, condition and diabetes type did not predict motivation. And that's an APA table. And let's just say, I think the only other thing I would do, and I recommend that everyone do this prior to doing any analysis, which I did not do here, my bad, is run descriptive statistics. So that's under descriptives. I checked all the variables of interest. So the reason is that I want to make sure that everything is cool here. So, okay, the reason I couldn't run that one test is eating disorder diagnosis was no. So that was the entire group. That's why that test could not be run. So, but just to make sure everything looks good here, make sure the min and max is good. I have a max of 222. It only goes to 25. So I made a data entry error. You want to correct that prior to running all of these tests. Okay. So you put that up top. And then once you've done your analyses, you just download the document. And in that downloaded document, these are the tests that were conducted. And here's our descriptives, our chi-square test, the Fisher test, correlation, our ANOVA, and regression. The tool can help you turn your 2 to 4 week project into 1 hour. I mean, that's the efficiency gain to be had here. In addition to the APA tables, the interpretation, the assumptions, you also have APA style references for all the in-text citations. And we have also appended a curated glossary of all the terms and symbols for each of the tests that were conducted. Okay. All right, a couple of other quick highlights, and then I want to really open up for questions here. There's different plotting options. So I can do a profile plot. I need 2 scale variables. I can do a histogram of motivation. Remember we said it didn't look like a bell curve? Nope, doesn't look like a bell curve. So you may want to transform that, but there's lots of different plots to be had here. Okay. We work through analyses, we play with the decision tree. When you're writing your data plan in your methodology and or applying to IRB, you have data plans on the fly, just click on the test and there is a downloadable, editable data plan to be had. Power analysis, select the test. And for different effect sizes, here's the sample size in 2 seconds. Downloadable, editable. Faculty, we typically give a lot of, a few sessions of free consulting. Students, though, that may need extra hand-holding, I just want to highlight that we really have low-cost group consulting sessions, $50. Is my data set up correct? Am I doing the right test? Do I understand the output? That can be enormously helpful for students. We also have share features. So this individual found the share button, great. So to share this project or any project, you just go to share and then click in recipients' names or colleagues' names, click share. Everything goes to them. The data, the plots, the analyses, the notes, all goes there. And you can see people that I've shared with, two users I've shared this with. When different notes are, when a project is shared, you can see changes that have been made. Okay. Here, a new plot has been made. There's a whole video library here, the whole reference manual here, and there's a set of courses to be had. And Melissa and Ashley can answer those questions, but there's 60 individual lessons that can accompany this, from all of the tests, the how to select the right test, the data management, and so forth. And I think with that, I will stop and just open up for questions.